Today, we're here to talk about the right way to modularize your app on Flutter. And just a second, yeah. So my name is Ramezanli, as you probably noticed, and I'm Android engineer at Capital One. Flutter is something I pursue in my spare time, and I'm really excited about it. But today, we're not here to talk about me. Today, we're here to talk about the challenges my friend Bob has been through lately. So as you may know, Bob is a good friend of mine, and he's a founder of a successful app. So last year, Bob implemented his idea into a business using Flutter, and his idea was his business is basically called Tinder, and it's Tinder for fashion. So instead of for Bob's user, instead of getting matched with other people, they would get matched with the right outfit, which is suited for them. And this was a huge hit. Bob was really successful. But as time were going on and Bob was getting busier and busier, he realized that, okay, it's too much for him to handle everything on his own. And he definitely needs some help on this. So he started the recruitments, and he hired a few engineers and also reached out to the community to invite people to join him. And he did that, and he was able to find people. So at the time, Bob's app structure looked like this. We call this monolith structure, where the entire code base is part of one space. And engineers joined the app. They started contributing day by day, and the app started growing larger and larger. But after some time, Bob realized that actually a new set of challenges are rising that he was not dealing with them before. The first one was that he realized build times are getting longer and longer. At the beginning, he was able to run the app in 20, 30 seconds, but now it's taking almost up to like 5 minutes for a single run. And it's just too much, and the development productivity comes down. Then the next issue was related to testing. Not just testing were getting longer and longer, but also Bob's team realized that as project getting larger, whenever a new commit comes in, there's a bigger chance that that new commit break other features. And also UI tests are getting longer times, and it's hard to manage them. The next one was regarding refactoring. That large code base was so hard to refactor. In fact, after Flutter 2.0 and the latest Dart releases came out, Bob was not able to try them out because the project was tightly coupled and everything was so dependent to each other that it took so much time for Bob to and his team to change the stuff. Similar to trying out new technologies, such as new statement management libraries, or for example, adding null safety to your application. That giant single code base was just a lot of work and didn't make sense business-wise for Bob. Not to mention that code conflict also became more and more of a problem. And also continuous integration for the app was taking longer and longer. For those who might not be very familiar with what CI is basically CI is some jobs which run all of the tests in your app. And whenever you have a PR up, it would run all the tests. And when they pass, it would merge the app. And when all these PRs are going into single code base, then this time would get larger and larger. The time would get longer and longer because we have to wait for all the other stuff to pass. So all of this made Bob think there should be a better way to handle this. Like, there's so many big companies out there with code bases even larger than mine. How would they do that? And that's when actually we started talking to each other. And Bob said, "Hey, Sam, what should I do about this?" And I introduced him to modular design, something that we practice a lot in Capital One. And so let's get deeper in what module is first. A module is a software component or program which is supposed to do only one thing, and you can deploy and test it individually. To have a better real life example, we can look at electricity outlets in a house or electricity system in your house. So in your house, the place you're probably watching this video from, wherever you are, there are many different electric devices, and each of them are designed in a way that they don't care if they're plugged into your house or your neighbor's house. If you grab your TV and take it to the house next to you, the TV will still work. And the reason is that the TV was individually built and tested, and now it doesn't care where it's used. It's able to be used anywhere. And same concept apply for software modules. They should be built in a way that they can be easily get decoupled from the project, and they can be shared in different places. So with that knowledge, Bob asked me, okay, what is module in Flutter? How would I do that? And the answer is that modules in Flutter are basically packages. Anyone who did any programming, Flutter probably is familiar with packages. And the packages are basically the dependencies and the libraries you pull into your app. And by definition, we have two types of packages. We have Dart packages and we have plugin packages. Dart packages are general type of packages written purely in Dart. One example is, let's say you have a logic for converting temperatures, right? So that has nothing to do with any platform, what platform you're running that. That's just a purely Dart code. Also, Dart packages can be have Flutter components to them as well, which makes them only limited to Flutter app and not other Dart related environments. But the second one is plugin packages, where in plugin packages, your Dart code is combined with platform specific code as well. And so the structure of these packages are pretty much the same, except the only difference is that plugin package has implementation of Android and iOS or web or whatever platform you're supporting, but Dart packages don't have. We're gonna cover this very shortly, but at this time, Flutter no longer recommends that you keep all the implementations in the same folder, and instead, it's recommending recommending a practice called Federated Plug-In packages, where you would have, instead of one package, you would have multiple packages, which each package has implementation for that specific platform. More on this a little bit later. If you want to call these packages in your app, you probably see this already. You can define the name and the version number. If you ever define a package like this, it means that you're getting that package from pub.dev website, which is the place where all the packages are published. But if you're here, you're mostly interested in more local packages that you want to use in your app. And you can define them using the path keyword. You can define the name, and below that, you can define the path keyword and just name the folder. And as you can see here, we had defined two different packages. One is inside the same file structure, and the other one is outside of that. So we can specify that by using .. And you can always pull packages directly from GitHub, where you just define the URL. And in case you want a particular branch that you want to pull in, you just define that using the keyword reference. With all that said, let's get back to Bob. So Bob has a team, all of them working on one monolith space. And now if you make the application modularized by creating multiple modules, which each one is specialized for one thing, now developers no longer would step on each other's toes. This would add additional benefits. So when Bob had a monolithic styled application where all designs and file were in the same module, in order to search for something or fix something, Bob had to spend a lot of time, and like a lot of the UIs were in the same place. Whereas in a more modular fashion, now each UI component or each feature has their own modules, so you know where to look at things. But it comes with additional benefits as well. So let's say Bob wants to modify one of the files in both systems. Let's say we have two identical ones, one modularized, one not modularized. When you change a file on the monolithic approach on the left, the scope that it affects is the entire code base. And by that means, when you make a change, because it's within that space, you need to check and run tests for all the other classes, make sure that one change hasn't broken everything else, and you're still working fine. However, in the modularized design, the change you made only affects that module. And also, technically, you should also test the main app as well. But in this particular example, if you make a change on profile module, the onboarding module doesn't care about that change. It can go as it is, and it doesn't have to be worried about what's happening in profile module. And so with all that, Bob finally found a key to the problem he was dealing with. And this way he would get shorter build times using modularization, the app is easier to test, faster to test, conflicts are much less since we have different spaces, continuous integration, the automation jobs are so much faster. And he can also explore new technologies right now. If you want to try, let's say, new state management, for example, river prod in one of the modules, he can, because that module is separate from other modules. Or if you want to try null safety in one of the modules, he can do that easily because he's dealing with much smaller code space. With all that knowledge, Bob then asked me, okay, that's pretty cool. So where should I start? What should I get, and which features should I pick up and modularize? What's the rule for that? And then we continue the conversation. So one way to modularize your app is by layer, where all your UI layer are in one directory, and all the other business logics, such as network repository and state managements, are in a different modules. And this is a really good way to do it, except again, the same problem come up when searching for UI components would be hard. If you actively implement the UI, then everything is merging into one space, which caused some problems. And the second way was by feature, where you have a particular module for each page. And this is also great. It will address a problem from the previous one, but then in this case, if you have a network call, which we're calling in different places, you would have to implement them again. So both has pros and cons, and Bob asked me, okay, which one should I pick? And I was like, okay, why not just combining both and have the best of both worlds? Now, this way you're able to have both all the business logics in their own separate modules decoupled, and also each feature would be its own module. And that should work pretty great. So, okay, Bob was very hyped at this time. He was ready to go. He was ready to tell his team to start. But I had to ask him, hey, Bob, could you wait? I have more stuff to share. It doesn't stop here. So there are other stuff you can consider modularizing in your app. Your application is very likely following certain theme or group of colors in the app. So making them in their own separate module would be really helpful. For example, when someone in the future, you want to have a major UI revamp, then changing the code in one place makes it change everywhere else. So as a real life example, I would imagine a lot of people who say this use Twitter, and they just recently changed their font across the app. Just imagine if every feature within Twitter had their fonts defined in their own separate module, then how much time it would have taken to change all the fonts across the app, versus if all the fonts were in one module and you would change it one place and the entire app, the font gets updated. I honestly don't know how they did it. I just know it makes sense for that to be modularized. The next one is shared UI components. There are many UI components that you probably share in a bunch of places. For example, a toolbar, app bar technically in Flutter world, or for example, let's say a calendar. As your app is getting bigger and bigger, you might use calendar in different places. And even if you start making new projects, you can share some of these UI components even in your new apps. So this is also that you can specify a separate module for each of them. Another really interesting one is generated classes. And I saw this tweet less than 1 week ago, if you see that date, where Matthew was asking, hey, is everyone also taking 20 minutes for each time they run their build runner? To give you a quick background, build runner is a library that a lot of developers use for generating some classes, especially for API model classes. And this the way it works is that you would define a certain you would define your type with certain keyword, and you would run the build runner command, and build runner would go your entire code base. It would check it, and it finds all those files which can be generated and generate those files. But the problem is that it doesn't have to go across the entire code base, right? Because there are only certain files that we want to be auto-generated. So as you can see, Dominic here is suggesting that why not just putting that into its own separate module, and it would work just fine and bring your build time much lower. And one last thing is just when you have some sort of SDK logic in your app, that's also would be a great opportunity for a module. And one popular example is a login SDK, for example. You would see all these different companies. They have login SDK where it's a module where they share across different apps. For example, Google login SDK is shared between Gmail, Google Maps, Google search app, and all those different things. So by the time I got here, Bob honestly got a little bit sleepy. And he asked, okay, is there anything else? Can I go? I already know so much, but there are like a couple of more things I wanted to tell him. Because there are certain things that are more specific in Flutter work, which makes your development, it would take it to the next step. So let's quickly cover them. And call this section modern plugin development. Let's say you have an app which has 3 packages, 3 dependencies, where you would define them in your popsec.yaml file. Traditionally, a Flutter plugin was a single package that enabled Flutter applications running on both Android and iOS. And this is the same thing that we discussed a little bit earlier, where the implementation for the package was in the same space as like all the different implementations for different platforms were in the same space. And your structure would look like this. But Flutter team actually started discouraging engineers to follow this approach, because at the beginning, it was only Android and iOS that Flutter was supporting. But now they're just going to support any possible platform out there. And it's just becoming much harder to maintain the code this way. Therefore, they introduced the concept of federated plugins. And the meaning of it is that instead of having all of your code for support of different platforms in a single package, federated plugins split different platforms into separate packages. This would have a lot of benefits, which we discussed shortly, but one of them is that it would be much easier for some tooling features such as pop.dev to know what exactly you're supporting on your app. But let's see how it works exactly. So we pick URL launcher as an example. URL launcher provides these 3 different methods to the app developers who want to use them in the app. It was previously, everything was in the same package, but with the federated plugins approach, we would have separate package for each one of these platforms. And another thing that we should make sure we add is an interface which connects all of these different components together. And the way it works is that the owner of the package, they care about a certain functionality in the app, and they want to make sure that all the packages for all different platforms, they should follow this, and they should be, these three functionalities should be implemented in them. And this would make code reviews for package owner much easier. And also, many of the problems we mentioned about modularization were, for example, if everything was in one package, there would be so many merge conflicts. You would add something on iOS, it could break something on Android, or you fix something for that, it would break on iOS. This would make so much more sense. And also you can have timely releases this way. You can release something for iOS and then wait for Android, whereas when everything was in the same package, you had to make sure you're releasing everything at the same time. And all this cool stuff are available to us because of the new PubSec format, which is called, which enables you to actually define what platforms you want to get your implementation from. For example, this is this one I got from URL Launcher GitHub, where it's specified, as you can see, for example, for Mac OS, the default package is URL_launcher.macOS_macOS, or for web, it is getting the specific web packages. So just to wrap up the session, I want to cover one more thing about, unfortunately, we lost Bob at this point. So we're just gonna continue the rest of the app for you guys. But this is also pretty interesting. So Flutter also enables the dynamic feature release on Android Flutter. And so in order to talk about that, let's cover some background about what Android bundles is. In an old days, well, not just old days, actually right now, you can, whenever you wanted to run an Android app or release it into the Play Store, you would create an APK, you would upload it to the Play Store, and then users would download it. The problem with this approach is that that APK would include all the information that your users may not need. For example, let's say your app as big as Facebook and you're supporting 30 different languages, and there's so many texts in your app, and you have so much, you're passing so much code with the APK, which all these different languages. And if I'm a French person and I only care about French language, the APK I'm installing on my phone still has the code for all different languages. Another significant example is different screen sizes. The APK that we used to ship would include the designs for all different screen sizes. But whereas when the user downloads an APK, they might only care about, for example, a tablet if they own a tablet. And Android addressed this problem with introducing app bundles, where the app that you actually build is now type bundle. And the way it works is the way I explained to you. On the left, you see APK, it would pull all the data in. But on the right, we only pull the data we care about. And in addition to all the stuff I told you, another great feature about app bundles is that it would enable dynamic feature delivery. And what that means is that if you want to release certain features, your users don't need to update the app to have that. You can just turn some toggle on, and they would be able to install it. For example, let's say their app is based on the English language, and now they want to have French language. By changing language, they can download that to part of the app that they need within their code base. Or if the project owner wants to test certain features or A/B test them, they can also benefit from that. Why am I saying all this stuff? All these things are available, or we can do them if we do modularization. And Flutter recently introduced support for that by introducing deferred components. Deferred components is actually can be a much larger discussion for itself that we're not covering here today. But just want to make sure you guys know that this is available, and at this time it's only available for Android, because iOS at the time of this conversation, based on my knowledge, doesn't support the app bundle logic. So with that, these are few references that I use for this talk, and thank you so much everyone for joining this. Yeah, I'll be happy to answer any questions. Thank you for the virtual class. Yeah, if you have any questions, I haven't checked the chat. Let me check. Okay. The resource slide, could you help me remember which one you're talking about, Robert? Are you talking about app bundle or the last slide? Okay. This one? With the references. Oh, okay. Cool. Cool. If there are no questions, we can give back time to everyone. Could you share those in the Slack channel too? Sure. Sure. Thank you. Yeah, thank you guys. I let you have how much? 10 minutes back from your evening. It was a pleasure speaking for you guys. Please hit me up on Twitter. I haven't shared my Twitter handle. It's just Sam Ramez. I'll be happy to stay in touch with you guys. Thank you.